Hi there, this is Math 8, Unit 3, Lesson 9. It's called Slopes Don't Have to Be Positive. Let's find out what a negative slope means. Today we're talking about what a negative slope means instead of positive. So far we looked at things like, a slope being 1/4, meaning going up 1 and over 1, 2, 3, 4, up 1 over 1, 2, 3, 4. And we've had that kind of pattern in our graph so far. Now we're going to make something that's not a positive, but instead make it a negative value, like a negative 1/4. That's the idea today. So you began with, first of all, looking at some lines and it said which one doesn't belong. And you had a discussion in class about the differences between all of these lines that you have right there. And so what you might notice, for example, like with this one here, S line, we can tell that it's going up 1 and over 3, up 1 over 3. So S looks like it's a 1/3 for a slope there. For V, though, it's going down 1 and over 3, down 1 over 3. So we might write that as a -1. We're going down 1 over 3. The T one seems to be going up 1 over 3, up 1 over 3. So T is also, looks like a 1/3. The U one, though, is going up 1. It's going to this point right there. So we're going up 2 over 3. So that's different there. So in terms of which ones are the same, which ones are different, which one doesn't belong, that depends on how you look at it. All right? You could say that S and T definitely have the same slope, so they seem to belong to each other. 2/3 has a different slope. It doesn't seem to belong at all. But yet we could say it goes with S and T, and because it's at least going up in that direction there. V seems to be one that maybe doesn't belong because it's going down and all the others are going up. Might be one way of thinking about that, right? It's definitely going down the page and the others are all going up the page. So maybe it doesn't quite fit in. But in some ways it does kind of fit in because look, it's similar to the third, at least the third. Of course, it's a negative 1/3. So I don't know. Is there a right or wrong answer there? Not really. It's really up for you to decide and talk about and think about and just see the differences there. Maybe S doesn't belong because it doesn't hit that point. Here we have 3 lines that hit 1 point together. They all belong because they hit a point. I don't know. You get to decide what you like. Let's take a look at our first question. Stand clear of the closing doors, please. Noah put $40 on his fare card. Fare card, for those of you who don't live by subway or bus areas, that just means it's like a little card you use to not to take cash around, to get on the bus or get on the subway, get on the train, whatever it might be. Noah put $40 on his fare card. Every time he rides public transportation, $2.50 is subtracted from the amount available on his card. All right, so he starts with 40 bucks, and then we have $2.50 subtracted, minus $2.50 every single time. How much money in dollars is available on his card after he takes 0 rides? Well, for 0 rides, he has $40. He's good to go. After 1 ride, we're going to subtract $2.50. And what's he going to have after 1 ride? He's going to have borrow from there, borrow and 10. Oops, sorry, 10 there. So we end up with 50 cents there and $37.50. Way to go. After 2 rides, well, we subtract again another $2.50, and now we're left with $35. After X number of rides, I don't know, but I could write an equation because we know that he's going to have $40 to start with minus $2.50 times X number of rides. So it depends on how many times he rides for how many times we subtract that $2.50. That's going to be how I figure that one out. Okay? So to graph that relationship, all right, to graph that relationship, we would look like something like so. After 1 ride, well, starting, he had $40 to start with, so we can plot that here at 40, no problem. At 1, he had $37.50, so we're going to put it right here. They already broke this up into halves for us. It's nice. At 2, we're at 35, and we can continue this down, 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 and this will just keep on going. Every day he's checking on, swiping his fare pass, ready to go, until finally he runs out of money somewhere about there. So there it is. How many rides can Noah take before the card runs out of money? Looks like 16. Where do you see that on our graph? We see it at 16 comma 0 is where it is in our graph. It's there at 0 because that means he has $0 left on his balance on his card, and that happened at day number 16. Okay, so again, this is showing you here that we can go down, right? We're decreasing by $2.50, right? So that's how that works there. Again, look back to what we had before. When you look back at this graph before, what's happening with V? It's decreasing at a constant rate. That idea of decreasing by a constant rate is the same thing that's happening here to Noah and his card, as he's using the money on his card each day to ride the bus or whatever he's riding, whatever it was. All right, travel habits in July, 9.3. Here's a graph that shows the amount of money on Hans' fare card for every day of last July. So he starts off with $20, and on day 1 he has $20, and then day 2, $20, and then $20. All the whole month he has $20. The entire month he has $20. Gosh, looks like not much is happening, huh? It seems to be the same no matter what you do. Like nothing is really changing there. What is going on, right? What do you notice? What do you wonder? I mean, my goodness, why isn't it going up? Why isn't it going down? What is Han doing every day? I don't know. Apparently, he has a fare card and he's not swiping it. He's not doing anything because he still has $20 all the way through the whole month. So maybe he decided to get a bike or a scooter and get some exercise, getting himself to school or someplace. I don't know where he's going. Okay. The first thing it says is describe what happened with the amount of Hans' fare card in July. In terms of what happens here, what do we see happening? It says, well, what we see happening is that he has $20 to start. He's at $20 all of July. There's no change in what happens with his fare card there. Plot and label 3 different points in the line. Okay, we can do that. We could plot a couple here. Well, let's see. Let's go with 3, 20. Let's go with 10, 20. And let's go with 20, 20. Boy, those are great little points there, aren't they? Right? Check. Write an equation that represents the amount on the card in July. Y after X number of days. Well, he has Y equals, in this case here, his rate, there's no rate there, 0x plus what he started with, 20. Well, what's 0 times x? Nothing. So Y equals 20 is all we would say. That's our equation. There's nothing else to it. There's no x value because there isn't one that we'd use there. Okay. What value makes sense for the slope of the line that represents the amounts of Hans' fare in July? In his case here, his slope is going to be equal to 0. And if we were to use this with some points, let's use our points here. Let's do the 20, and also the 10, 20. Okay. Okay. If we were to do the difference here, this is 20 minus 20 over 20 minus 10, which is 0 divided by 10. Okay. I have nothing, and I divide it by 10. I have nothing. How many does everybody get? I have 0 cookies, and I'm going to share my 0 cookies with 10 friends. How many cookies does everybody get? 0. Why? Because I don't have any. So our slope's going to be 0. So for Han, he has no slope on there, and that's all there is to it. Okay? Let's take a look then at the, are you ready for, no, look at number 4, 9.4. Here is a payback plan. So Elena borrowed some money from her brother. Oh boy, never borrow money from your brother. She pays him back by giving him the same amount every week. The graph shows how much she owes after each week. So here it is, after 1 week, she gives him back something. So she's there. Week 2, she's here. Week 3, she's here. So she's paying back money at a constant rate until she finally doesn't owe him any more money. Okay? What is the slope of this line? So in this case here, our slope is going to be always is, our y over our x value. In this case, we can see that we're going down 1, 2, 3. We're decreasing by 3, and that we're going over 1. So our slope is actually going to be -3 for this line, because we're going down 3 over 1, down 3 over 1. How do you know whether the slope is positive or negative? Well, we're going to recognize that it's negative, and perhaps you can use words like it's going down or it's decreasing. And those are all things that describe this line. Because she's paying money back, the amount she owes is becoming less. So our line is becoming less in terms of the dollar amount that's there. Okay? What does the slope represent in this situation? In this situation, what it says is that she is paying $3 a week in order to decrease the total amount she owes. She's paying $3 a week in order to decrease the amount she owes. She began by owing him $18, and she pays $3 every week to decrease the amount that she owes. So the amount she owes is getting less every time she pays. How much does she borrow? We just answered that actually. We would say 18. That's going to be your y-intercept, isn't it? It's where it started at, which is here at 18. And how much time will it take for Lena to pay back all the money she's owed in terms of her time? Here's her time. Well, when does money equal 0 is what we're asking about here. And that's going to happen right here at week 6. So it will take her 6 weeks to do that there. Okay? Now with the same question, you could write an equation for this, right? We could say y equals mx plus b. Do we have a slope value? Sure we do. -3. Do we have an x? Yep, we have a y. And do we have a y-intercept? Sure. 18 is where it starts, plus 18. And so we can use that same graph and we can turn it into an equation using what we've just answered there. Alright, so in summary, the idea is that we can make a graph go down. We can have a negative slope. It can decrease. That's okay. This is a little like that snow problem from the last one. The last time we had snow and it was snowing someplace and it said that it snowed like half an inch a day, right? Or half an inch an hour, and it went like this, right? Half an inch to 2 to 4, went like that. Well now this snow here says that it's already 30 inches deep on the ground, but then it gets warm and it starts to melt. Well, if it's melting, we're going to be decreasing. And decreasing is okay. It just means my slope will be negative. And that is all right. Okay? If I have less snow, I'm going to be decreasing. I'm going to end up with a negative slope. So graphs with negative slope often describe a situation where some quantity is decreasing over time. And that is okay to do. So sometimes you might have a negative slope. That's all right. Sometimes though, what's interesting we saw today is that sometimes a slope can be positive, negative, and it can even be, surprise, surprise, 0. So a 0 means there is no change in value. So this is the case here. There's no change in value. It stays exactly the same. So we can have slopes that are positive. We can have slopes that are negative. We can have slopes that are no change. It really doesn't matter. That's just different ways of showing what's happening with an equation or a situation. Let's take a look at your homework for tonight. Number 1. Suppose that during its flight, the elevation, E, in feet of a certain airplane and its time, T, in minutes since takeoff, are related by a linear equation. Consider the graph of this equation with time on the horizontal and elevation on the vertical. For each situation, decide if the slope is positive, negative, or 0. All right, so here is our, we said time is here, and here's our elevation here on the vertical. So a plane is cruising at an altitude of 3,700 feet above sea level. So 37,000 feet here, it's cruising. The plane is just flying along, cruising. Is it changing? Nope, not changing at all. It's cruising. Because it's cruising, our slope is going to be 0. For B, it says the plane is descending at a rate of 1,000 feet per minute. Descending. Like that. It's going down, right? So that would be a negative slope. A plane is ascending at a rate. So now we're going to be going up. And up would be positive. Okay. Number 2. Okay, here's the question on this page here, but the graph is on the next page. A group of hikers park their car at a trailhead and hike into the forest to a campsite. The next morning, they head out for a hike from their campsite, walking at a steady rate. The graph shows their distance in miles from the car on the day of their hike after H hours. So they're cruising along, they park their car at a trailhead there, and they hike in the forest, into the forest, okay, to their first little campsite. So here's their little tent, having a good time, okay. The next day, they start their hike and start walking at a steady rate away from the campsite. Okay, that's our picture. Well, let's take a look at what they're doing. How far is the campsite from their car? How far is the campsite from their car? Well, let's take a look here. Well, we can see here that, first of all, the graph shows how far they're walking at the steady rate. This is our steady rate graph. Okay, this is our distance, and oops, bring it back down there. Here's our distance here, and here's our hours walking. We started with the graph already at 4. That's where we began, which means that we already were 4, whether that be miles, I'm guessing miles away from the car. We parked the car and then we walked into the campsite. This is a graph that shows how much they hiked. So we would say that the car is 4 miles away. And the reason for that is that's our y-intercept. That's where they started the camping from. Write an equation that describes the relationship between D and H. Okay, to do that, we're going to say that D, which is our y value, D is equal to a rate, we'll come back to that, okay, times H. And in this case here, we're going to add our starting point of 4. So we need to find our rate right here. Our rate in this case, looking for points, we're going to be going up 1, 2, 3, and over 1, double check, 1, 2, 3, and over 1. So our rate is 3. I could write 3 over 1, but really 3 is just fine. Okay? After how many hours will the hikers be 16 miles from their car? Well, to solve that there, now I have an actual distance that I can use with the equation. So I have my equation, distance equals 3h plus 4, and we're going to use the 16 right here. So 16 is going to be equal to 3h plus 4. We subtract 4 from both sides. That goes away. So we have 12 equals 3h. We divide both sides by 3, and 4 equals our h. So after 4 hours, they are going to be 16 miles away from the car. Alright, next question. Elena's aunt pays her $1 for each call she makes to let people know about her aunt's new business. The table shows how much Diego gets for washing windows. So Elena is $1 per call. Alright, gotta keep that in mind there. So let's go to our table. Let's take a look at Diego here. Okay, so we know that Elena, she gets $1, right, for every 1 call. For Diego here, before I go much further, he's making $30 washing 27 windows. Okay, that means he's making more than $1 per window. Because if he was only making $1 per window, it'd be 27 times 1 to get you to 30. So he's making more than $1 per window here, isn't he? Right? So what is Diego actually making? Well, to do that, we don't want to find out what his rate would be there, or his constant proportionality. that's at 30 over 27, which we can reduce that down if we wanted to and think of fraction terms. 3 goes into here 10 times, and 3 goes into here 9 times. So you're looking at 1 and 1/9, or as a decimal, it's like 1.11. Okay, so if you're thinking about money, Diego's making about $1.11 for every window that he washes. So for him, it's like $1.11. Elena, for every call, gets $1, and he gets $1.11 for Diego. Okay, so we already know that in one sense, that Diego is making more than Elena is in some ways. Okay, that Elena's making $1 for every call she makes, and Diego's making $1.11 for every window that he washes. Okay, so in one sense, in terms of the quantity of something being done, Diego makes more money than Elena. Well, let's take a look at the questions now. Elena makes more money for making 10 calls than Diego makes for washing 10 windows. If you multiply this by 10, you'd get 10. You multiply this by 10, you would get more than 10. This would not be a true statement. That's not going to be true because Diego makes more per thing that he's doing. Diego makes more money for washing each window than Elena makes for making each call. This is going to be a true statement, and we showed that right there. He gets $1.11 per window, she gets $1 per call. Elena makes the same amount of money for 20 calls as Diego makes for 18 windows. That's a great question. Well, we know that for Elena, 20 calls is going to be $20. Now for Diego, that 18 windows, let's use this number right here if we would. Let's do our rate of 10/9, and let's do 18. Let's pretend to put back in our chart here. 18 times 10 over 9, right? That's our constant proportionality here, but as a fraction. If we reduce that, that becomes 1 over 2, and 2 times 10 is 20. So if he did 18 windows, he would actually make $20. So they make the same amount? They sure do. That is true. Diego needs to wash 35 windows to make as much money as Elena makes for 40 calls. Well, her 40 calls is $40. That's easy enough there. So for Diego, 35 windows, again we go back up to here, 35 windows, and I can multiply it by 10 over 9. Alright, 10 over 9 if we wanted to do the 10/9 there. That's going to be 350 over 9. And 350 over 9 is about $38 and some extra cents. Okay, so $38 is less than 40. So is he going to make $40? Nope, he won't make $40. That's not true. The equation y equals 9/10 x, where y is dollars, x is windows, represents Diego. That's close, but not right, because that our rate, our constant proportionality here, right, our slope has to be 10/9. That's what we said. 10/9 is what we're looking for. That's 9 over 10. So that's not going to be true. The equation y equals x, where y is number of dollars, x is number of calls, represents Elena's situation. Well, every time she makes 1 call, she gets $1. 2 calls, $2. This is very true. That's her situation there. Y equals x. There's no big change. All right, and our last one. Each square in the grid represents 1 unit on each side. Match the numbers with the slopes of the lines. Okay, so take a look here at what you got. You got a point and a point. We're going up 1, 2, 3, 4 over 1, 4, 1. So we're going 4 and 1. That seems to match point number 3. Here we're going up 1 and over 1, 2, 3, 4. Right, so we're going up 1 over 4. That seems to be right there for B. And this one we're going down 1 over 4. So this is going to be C. CBA. All right, that's it. Have a great day.